Lesson 13 today. We're going to talk about substitution. So there's an axiom, a substitution axiom, that says that if two expressions, for instance, A and B, are equal to one another, then you can substitute A anywhere that B is located. So that literally means that you could say that A equals A and B equals B, right? So in that regard, if this is the case, then this is also the case. If A equals B, then I could say 2A plus 3B equals, let's say 5B. Because A equals B, we could sub in and say 2B plus 3B equals 5B. And we could solve that. We could say 5B equals 5B. And that would be true. Because we know that A is equal to B. So we could put B in and solve for it. This is called the substitution axiom. And it just means that when you have two terms that are equal to each other, you can swap them out for one another to make your equation solvable. Just like we did here. Sorry, my throat's about to go. So let's begin with a example problem and talk about that in regards to x and y coordinates or linear equations. Just clear this page. There we go. It's just going to take us a minute. It's getting warmed up this morning. So here's example problem 13.1. And we are given two linear equations. Here's the first one. And we have the second one. All right. So we're going to use substitution. We know here that x is equal to y plus 5. So anywhere we see the variable x, we can substitute in y plus 5. So that means we can rewrite this statement here as 3 times y plus 5 instead of saying x, because we know the value of x. X is y plus 5. So let's sub it in, even though it is a expression and not a term. We could still use it because we know it's true. Here, we know what x equals. So let's put it in for x. Okay? Instead of saying x equals 4, we just have an expression here. So now we distribute, just like you would for any other problem. And then we can combine and we can flip this over to a negative. So that would be negative 10 is our result, because 5 minus 15 is 10, negative 10. And then y equals negative 2. So now all we have to do to solve for x and figure out exactly what x equals is put negative 2 in for the y value. So x is going to equal negative 2 plus 5. So x is going to equal 3. So now we know that x is 3 and y is negative 2. And here is our point on the coordinate plane that is the resulting answer. All right. Does everybody see how we did that? We took this and put it in here. And then once we got the answer to y, we took this and we put it back in to here. So it's kind of like a circle. We have to solve for x in order to solve for y. So let's try another one. Let's do 13.2. So we have 3x minus y equals 11, and then 2x plus 3y equals negative 11. All right, so what we have to do first is to solve to find something that we could substitute. And the thing you want to look for is a single variable by itself without a constant. So let's do this one here. If we simplify it a little bit, let's flip our sides around. This would be a negative y equals 11 minus 3x. And if we multiply or divide everything by the negative 1 here, because we want this to be positive. So if we multiply everything by the negative 1, in order to get rid of the negative 1, we end up with y equals negative 11 plus 3x. All right. So now we know what y is. So we can drop this in for the value of y. Okay. So we could rewrite this 2x plus 3 times, and then this is the value of y, equals negative 11. And now we can solve for x. So let's start distribution. And this is going to be a negative 33. And this is going to be 9x. Now we can combine. Sorry. Because this will be a positive when it goes to this side. So x is equal to 2. Right? So now we could put x in here and solve for y. So y is equal to negative 11 plus 3 times 2, which is 6. So y is equal to negative 5. So our answer would be written as a point. X is 2, y is negative 5. And that's our result. Okay? And if you want to check your answer to see if you got the right answer, all you have to do is go back to one of these. Let's pick this one right here because it's got both of those. Or you could pick this one, it doesn't matter. Let's sub in for x. 2 times x, in this case x is 2, so that's 4, plus 3 times negative 5 is going to be, well, that'll be a minus, won't it? Minus 15 equals 11, and actually it equals negative 11, and that's correct, negative 11. So we know that this is a true result. We found the right one. All right, we have one more scenario here. Let's do 13.3. And we are given x plus y equals 20. And 5x plus 10y equals 150. All right. So first of all, let's pick which one we want to solve for. Let's solve for x. So that would end up being x equals 20 minus y. That's our x value. So let's sub that in. So 5 times 20 minus y plus 10y equals 150. Right? That's 100 minus 5y plus 10y. And now we could combine and flip. So we're going to have a negative 5 and a positive 10. That's a 5y. And if we bring the 100, we subtract it from both sides. That's going to leave us with 50. So y is equal to 10. So let's sub that in up here. X is equal to 20 minus 10. So x is equal to 10 as well. And if you look up here, 10 plus 10 does equal 20. So our answer is correct. And our result is going to be 10 for x and 10 for y. And that's our final answer. So if that's what you got, very good. On any of these, as we go through, you can always pause and work the problem. You don't have to wait for me to tell you. You can look at what you're given, pause, work the problem, and then press play. Just to see if you're following along and you're understanding what's going on. We've done these before. We did these last year. We did a lot of these last year. So I didn't ask you to stop and do any of them because I know you guys are really familiar and you just need a refresher. So moving on, we're going to talk about the area of an isosceles triangle. We know that an isosceles triangle is one that has, there we go. It has equal sides right here, which makes it have equal angles here, right? So that means that this length is going to equal this length regardless. Now we know the area of a triangle. To find the area of a triangle, we say base times height divided by 2. Well, what if we're not given the height of an isosceles triangle? Let's say this is 5 and this is 4. We know that this would be 5 also, but we don't have a height. So how can we find the height of our triangle in order to find the area? Well, we know that because these are equal in the isosceles triangle, that this point is centered directly over the middle. We know that mathematically and geometrically because that it has to happen that way because these are exactly the same length. So when they meet in exactly the center of this line down here. So that being said, we know we can draw a line here, and this would be the height, and because it's exactly center, this line will be perpendicular to the base here. And because it's exactly center, we could take this measurement and divide it in half. So we have 2 on this side and 2 on that side. So now we know we have a right triangle here with a 2 for the base and a 5 for the hypotenuse. So we can use Pythagorean's theorem in order to find the height of this triangle. And then we can use that to find the area. So let's use Pythagorean's theorem to find this height. We know that a squared plus b squared equals c squared. C squared is always the hypotenuse. In this case, the hypotenuse is 5. So that's going to be 25, right? Because 5 times 5 is 25. And a, we'll take that as the base. 2 times 2 is 4. So in this case, b is going to be the height. So we'll say height squared. So now we're going to take the 4 to the other side. We're going to say h squared equals 21. That's what we have left. Now we're going to unsquare this. And we're going to say the height equals the square root of 21. So now we have a base and we have our height. And the base of the triangle is the total. So that's 4. And then the height is the square root of 21. So now we can do our area calculation by saying 4 times the square root of 21 divided by 2. We can factor 2 out of this 4, so that's going to equal 2 times the square root of 21 is the area of this triangle. And this particular triangle is in centimeters, so that's centimeters squared. And that is the final answer. And that's pretty straightforward if you understand how an isosceles triangle, the properties of an isosceles triangle, how it is set up, and what the values are. All right, so that is all we have for lesson 13, and I will see you in lesson 14.